As we understood the difference between stateless application and stateful application, now let's try to put the same example into deployment architecture and see how it fits into this. Okay, so we have seen one example related to weather. I have a separate video also explaining stateless application and stateful application. You can watch that video as well. I have given that link in the description. Now, what we do, this weather API application will try to put this into this deployment architecture. This is the typical deployment architecture. When we create the deployment, it internally creates the replica set and it creates the three pods, pod 1 and pod 2 and pod 3. You can see a random string appended at the end. Okay, then to give the access to this pod to the external world means any user wants to reach to this pod, there is a service created in the backend. We call it as a load balancer service, and the job of the service is to automatically distribute the traffic among all the pods. Okay, and it distributes the traffic in round robin. The default behavior is it distributes the traffic into the pods in round robin fashion. Okay, so what we do now, we try to fit that example into this. Let's say a user wants to know the weather of Bangalore. Okay, he will send the request to load balancer. Load balancer, let's say, gave the request to pod 0. Pod 0 communicated with the database, got the result, and send it back to the user. And now there is a new request coming, like a user wants to know the weather of Delhi. Request will come to load balancer, goes to this pod, goes to database, and user got the response. He wants to know the Kolkata result. He will send a request here. That request will go to different pod now. He will communicate to the database, get the response, and serve it. So if you see, load balancer can forward the request to any pod and any pod is able to serve the request because none of the pod is required is maintaining any dependent data here. Like first request can come here, second request can come here, third request can come here. Since there is no relation between or there is no continuation or session data is required to serve a new request, so any pod can independently serve this request. Okay, now what we do, we saw one more example, right? We saw this example of StatefulSet where we create the game and that game will have my balance, okay, my points, how much of bullets I have and all my movement, all the information the session stores. This is the example of stateful application. What we do, we try to put this example also into the deployment architecture and see whether it fits into this or not. Okay, the deployment names are weather API here. Actually, assume that this is the game API only. Okay, what we do now, let's say user will first come to the website and create the game. So let's say that request come to the load balancer randomly forward that request to assume this pod. So what happens, a user session will be created in this pod. Okay, so he created the game and game session is created in this pod. Okay, next time let's say user did a mouse click. Okay, that request came to the load balancer and that request load balancer can forward that request to any pod. Let's say load balancer forwarded that request to this pod. Now this pod doesn't know any information about this game session because it's in the local storage of this pod. Okay, so this pod, when it creates the game, it maintains a local storage for his current balance, his total points, total energy available, bullet balance, and everything that is available in this pod. If next request to update the balance or something comes to this pod, then this request will not be served. It will be rejected, and that's how we lost. We will lose our entire communication here. So this shows that the stateful application where stateful application who maintains the local storage cannot be fit into deployment architecture because in the deployment architecture service will randomly forward the request to any pod. And you may say skipping the service, how about sending the traffic always to this pod? These pods have a random names. They don't have a constant name as well. So if by any chance if we restart this pod or if this pod got crashed, the name of the pod itself will get changed. Okay. So the reason Kubernetes have came up with a controller called stateful controller, stateful set controller. So now we talk about the stateful set controller and we see how it works.